You've just been handed a file. Maybe it came in through an email attachment report. Maybe your EDR flagged it. Maybe someone on the team pulled it from a compromised host. Either way, you don't know what it is yet. What do you do first? You don't run it. You don't open it. You hash it. This episode is about the first 3 moves in a malware triage workflow, the sequence I reach for every single time I encounter an unknown file. By the end of this, you'll have a complete triage pass from what is this thing to confirmed malware family identification, and we're going to do it in under 5 minutes. Welcome back. If you missed episode 0, I recommend starting there. It covers what MalChela is, how to install it, and the philosophy behind the toolkit. This episode, we're getting our hands on a real sample and walking through the first 3 tools in the triage sequence. Before we do the first run, a quick note on API keys. 2 of MalChela's tools, the malware hash lookup and file analyzer, can query VirusTotal and MalwareBazaar for threat intelligence. To use them, you'll need free API keys from both services. Once you have them, create 2 plain text files in the MalChela project root, vtapi.txt with your VirusTotal key, and mbapi.txt with your MalwareBazaar key. 1 key per file, nothing else. If you skip this for now, MalChela will prompt you the first time you run a hash lookup, but I'd recommend doing it now. Before you do anything with a suspicious file, you establish its identity. That means generating a cryptographic hash. Why does this matter? A few reasons. Chain of custody. If you're working an incident where chain of custody matters, you need to be able to demonstrate that the file you analyzed is the same file you collected. The hash is your proof. It's the digital fingerprint. Deduplication. Once you have a hash, you can instantly check whether you've seen this exact file before. Same hash, same file, byte for byte. That's powerful when you're triaging a large environment. Threat intelligence lookups. Hash-based lookups are the fastest path into existing threat intel. In this episode, we'll show 3 different ways to interact with the toolset, 2 via command line, and then in the GUI. Like we said, the first thing we want to do with our suspicious or evidentiary file is to hash it, and for that we'll use the utility conveniently named hashit. From within our MalChela directory, we'll run target release hashit, followed by the path of the file in question. You'll get 3 hashes back, MD5, SHA-1, and SHA-256. We're generating all 3 because different platforms prefer different hash formats. VirusTotal accepts all of them. MalwareBazaar tends to prefer SHA-256. Your internal ticketing system, or SIM, might store MD5. Having all 3 in one shot means you're covered regardless of where you're going next. Note that in the terminal it says that the output was not saved. All of the MalChela tools support saving output in text, JSON, or Markdown. By default, the output is not saved. You can use the command with the output syntax if you want to export results, or just copy and paste from your screen. Next, we're going to look at the file's properties, and we'll do that with File Analyzer. There's a lot in this output, and we'll do a deeper dive in a later episode. For now, I want to highlight 2 things, entropy and PE header fields. A high entropy, above 7, strongly suggests the data is either encrypted or packed. High entropy is a signal, not a verdict. A legitimately compressed installer will also show high entropy. What you're doing with this number is raising or lowering your suspicion level. It's one data point in a constellation of indicators. Don't let high entropy alone be your conclusion. Let it inform your next question. PE header basics. If this is a Windows executable, a PE file, you'll also see fields pulled from the PE header, things like compile timestamp when the file claims it was compiled. Timestamps can be forged. Sections, the named segments of the executable. You want to note unusual section names, or sections where the raw size and virtual size are wildly different. That's often a packing indicator. Imports, what Windows API calls this file is referencing. Even a brief glance at the imports table tells you a lot. Network functions, registry access, credential-related APIs. These are the things that inform behavioral expectations. Again, we'll go deeper in a later episode. For now, you're getting a picture of the file's surface area and taking notes on what stands out. All right, we've got our hash. We've got a rough sense of what the file looks like structurally. Now we find out if anyone else has done the heavy lifting on this sample. That's what malhash does. It submits your hash to VirusTotal and MalwareBazaar simultaneously and returns the results. A couple things I want to flag before we run this. First, in this case, we're passing the hash of the file, not the path as we did in the previous two tools. Second, why two platforms? VirusTotal and MalwareBazaar are not redundant, they're complementary. VirusTotal aggregates results from dozens of AV engines and gives you a detection ratio. It also stores behavioral analysis, sandbox reports, and community comments. MalwareBazaar is a curated malware repository run by abuse.ch, with malicious files tagged and classified by researchers. If your sample is in MalwareBazaar, you'll often get a malware family tag directly. Together, they give you both breadth and depth. Right off the bat, we can see 40 out of 57 detections on VirusTotal. There's also a permalink to the VirusTotal report to go deeper in depth if need be. If we scroll down to the MalwareBazaar results, there it is. That's a redline stealer detection. You've gone from an unknown file to a confirmed malware family in under 5 minutes using 3 tools and 0 sandboxing. Knowing the malware family tells you what category of threat you're dealing with and the threat actor's probable intent was. Redline is an info stealer. It's going after credentials, browser data, crypto wallets. That context immediately informs your containment priorities. What systems do you look at next? What data was potentially exposed? What do you tell the client? Another way of analyzing the same file set is to go through the MalChela toolkit CLI. We'll use the number code for hashit and give it the file name when prompted. There we have our hashes. Next, to run File Analyzer, we'll choose option 4. Again, give it the same file path. And we have our results. And lastly, we can run malhash. Give it the hash value. And again, our results. Now we'll hop over to the GUI. We'll start with hashit. Browse to our file. And click Run. For File Analyzer, again, browse to the file. And select Run. Lastly, we can head over to malhash. In this case, we'll paste in our hash value and select Run. That's it. 3 different ways to approach the same executable. Be sure to check back for the next episode, where we'll go from strings to signatures.